In this video, we're going to get an overview of requirements engineering. Requirements engineering is made up of several activities. The various activities you see here don't always overlap neatly with a single framework activity. Let's go over them briefly. Inception is where you try to understand the problem. Elicitation is where you actually collect the requirements. Elaboration is where you model the requirements. Negotiation is where you negotiate the deliverables. Specification is where you describe the requirements. Validation is where you check the requirements. And requirements management is managing changing requirements. Okay, let's look at each one of these and try to match them up with the framework activity in which they would occur. And remember, the framework activities are something you should know by heart: communication, planning, modeling, construction, and deployment. And there's also the possibility that one or more of these requirements engineering activities might be more suitable under an umbrella activity. Okay, so let's pause and think here. Look at these activities and tell me what framework activity or umbrella activity they would occur in. Okay, ready? For inception and elicitation, I think it's pretty straightforward that these belong to the communication activity. Requirements elicitation is more or less synonymous with requirements gathering. While we're at it, requirements elaboration is the same thing as requirements analysis. So that's where you're going to build the analysis model. Negotiation, to me, seems like something that happens during planning. So I'm going to match it to that. Specification and validation, those are activities where you are describing the requirements more precisely and checking that description. For that reason, I would also match these with modeling. Although I think the case could be made, since validation is a kind of testing, you could probably put it under the construction activity also. Finally, requirements management is about managing changing requirements. And that's something you have to do during the entire course of the project. So I would call that an umbrella activity, perhaps falling under configuration management. Let's take a look at the requirements engineering activities individually. During inception, stakeholders are identified. Again, stakeholders are anyone who has a stake in the project's success: customers, users, developers, and so on. A key question that should be asked to each person you talk to at this phase is, who else should I talk to? That will expand your circle of stakeholders and better ensure that you have accounted for everyone. Of course, you should recognize that having many stakeholders means that you'll hear many different points of view on what the project should entail. But you should expect that at this point in the process. Ideally, you'd like to merge those perspectives and get everyone on the same page. Some of the initial questions to ask are, who's behind this project? Who's going to use the product? What are the economics of the product? And is there anyone besides us, the developers, who we have to collaborate with for the solution? Before we talk about requirements elicitation or requirements gathering, I want to give you a few quotes that Pressman references on the importance of understanding the requirements. The first is by Fred Brooks of No Silver Bullet fame. He says, "The hardest single part of building a software system is deciding what to build. No part of the work so cripples the resulting system if done wrong. No other part is more difficult to rectify later." Casper Jones says, The seeds of major software disasters are usually sown within the first 3 months of commencing the software project. And Brian Lawrence says we spend a lot of time, the majority of the project effort, not implementing or testing, but trying to decide what to build. I'm sure you can find other quotes out there on the web about the importance of getting the requirements right. It's a bit remarkable that so many working software engineers put so much emphasis on requirements, in part because software engineering seems like it's something that should be focused on design and construction. But here we have a bunch of real-world software developers telling us that the most important part of software engineering is communication. Wow. Here's a slide that I no longer see in the slides that Pressman includes for instructors, but I think it's very instructive information, so we're going to talk about it. The question might be asked by the average software developer of why it's so difficult to understand what the customer wants. And these are all very good reasons about why it's difficult. You have problems of scope. Maybe there's not a clearly defined boundary for the system, or the customer starts giving you information about unnecessary detail. There are understanding problems, which are legion. Customers might not be sure of what they need. They don't understand the computing environment, or maybe they don't understand the problem domain. They have trouble communicating their needs. They omit relevant details, or they give conflicting or ambiguous requirements. These are all real problems with requirements elicitation. And finally, one of the biggest problems involving requirements is that they change over time. That's a lot of things that can impede understanding. But there's one feature about this slide, specifically about the bullet points on this slide, that I find quite interesting, and I wonder if you spotted it as I was quickly going over these points. If you're not sure what I'm talking about, pause the video and try to figure out an interesting feature of nearly all these bullet points that should make you a little uneasy and a little suspicious that this slide is telling the whole story about understanding what the customer wants. All right, I know that question was a bit vague, but here's what I find very odd about that slide. Think about communication. If I type the words "communication is a" in Google, how do you think it would try to complete it? Well, I can tell you that communication is a two-way street would be near the top of the list. Communication involves two people. And problems with understanding in communication also involves two people. But if you look at the previous slide, the bullet points make it seem like the customer is always the one who's at fault. Well, what about if the developer doesn't understand the jargon that the customer uses? Whose fault is that? Or what if the developer doesn't have a good understanding of the problem domain? Whose fault is that? I remember interviewing for a job at NASA. They were doing work related to aviation and air traffic control, where the software was mission critical and had to work correctly the first time. At one point, I asked one of the interview team, given the nature of your work, how important is it for the software developers to understand the problem domain? And their answer did not really surprise me. They told me that the domain knowledge that they have is as extensive as anybody's in the industry. If you work here, they said, you'll become an expert on the aviation domain. So don't put all the blame on the customer if understanding is a problem. Make sure you, as the developer, have done everything you can to achieve a good understanding. One way of eliciting requirements is through collaborative requirements gathering, or CRG meetings. These are meetings that are attended by all interested stakeholders, and the idea is that you want the meetings to be structured so that you cover everything you need to, but at the same time, you want a relaxed atmosphere that encourages the free flow of ideas. Pressman sees the facilitator as key to striking this balance. During the meetings, you identify the problem, break it down into pieces, and propose various solutions for them. And then you discuss the different alternatives. We'll talk more about collaborative requirements gathering meetings in the next video. Here's Pressman's activity diagram of a CRG meeting. The rectangles are activities, the diamond denotes alternative paths, and the parallel bars represent activities that can take place concurrently. The activity diagram is a kind of UML diagram that's similar to a flowchart. Over the course of the next few slides, I'll show you bits and pieces of UML diagrams, but we'll look at UML diagrams in detail in the next module. These are some of the elicitation work products that Pressman talks about. They include statements of feasibility and scope, a list of participants, and a description of the technical environment. The last three items here are of particular importance: a list of requirements and their associated constraints, a list of usage scenarios or use case scenarios, and any prototypes you may have developed to help refine the requirements. We're going to devote all of next week's module to the analysis model and the diagrams that are produced by it. There are 4 elements to the analysis model: scenario-based elements that describe how users interact with the system, class-based elements that describe the objects in the system and the relationships among them, behavioral elements that describe how the system responds to external events, and flow-oriented elements that describe how information is transformed as it flows through the system. Use case scenarios are one of the most important work products in requirements engineering. They're simply narratives about how a user or an external entity will interact with the system. For example, a use case scenario for ordering an item online might say something like, the customer goes to the website, the customer searches for the item, when a list of alternatives appears, the customer chooses the desired alternative and enters the desired quantity, and so on. Of all the questions that the use case scenario answers, the primary one is, what main tasks or functions are performed by the actor? The other questions relate to the context in which the scenarios take place. In contrast to a use case scenario, a use case diagram shows the system boundary and the actors or external entities that interact with the system. The rectangle is the system boundary, and the bubbles are titles of use case scenarios. This diagram gives a good overview of which actors are involved in which use cases. While this diagram gives a broad overview of the use cases in the system, the text-based use case scenarios are much more important because they give you the details of how the use cases are carried out. This is an example of a class in a class diagram. It contains the name of the class, sensor, the properties of the class, name, type, location, and so forth, and the operations of the class, identify, enable, and so on. It should be fairly easy to see how this class diagram matches up to a class in an object-oriented language like Java. This is a representation of a state in a state diagram. It contains the name of the state, variables included in the state, and activities that may occur when the program is in that state. All of the diagrams that we basically got a glimpse of over the last few slides will be looked at in much more detail in the next module. Negotiating requirements involves deciding which requirements are the most important given the resources that the team has. It's basically a negotiation among stakeholders that's informed by the developers, because it's the developers who can provide good estimates of how much effort it will take to implement each of the requirements. As in any negotiation, the best case scenario is when everybody comes out feeling like they got what they wanted. Requirements validation is where you check that the requirements make sense within the context of the overall system. This is where you determine if there are any conflicting requirements. One of the most important questions here is the requirement really necessary? It's going to take time and money to implement it, and if it's not critical to the final product, maybe you should leave it out. Another very interesting question in this list is the requirement testable? If it's not testable in some way, it may be difficult or maybe even impossible to tell if the requirement was implemented correctly. And that's it for this video. In the next video, we'll briefly go over an example of a collaborative requirements gathering meeting.